हेलो बच्चों, वेलकम टू आवर एम्स क्लासेस। आज वीडियो लेक्चर 7 में टाइप ए मैंने बताया था। आज टाइप बी का न्यूमेरिकल सॉल्व करूंगी। तो अ हॉट प्लेट ऑफ एन इलेक्ट्रिक ओवन कनेक्टेड टू अ 220 वोल्ट लाइन हैज टू रेजिस्टेंस coil A and B, each of resistance 24 ohm resistance, which may be used separately in series or in parallel. What are the current in these three cases? So here 220 volt two resistance coil A and B, each 24 ohm, and which may use separately in series or in parallel. So first of all solve in case of series. सीरीज में इनको यूज कर दिया गया। तो और दूसरा केसेस है पैरेलल में, और इन तीनों केसेस में एक सीरीज में और दूसरा केसेस पैरेलल में और तीसरा केसेस इस तरह से कनेक्शन किया गया है। दिस इज द कनेक्शन ऑफ ऑल थ्री रेजिस्टेंस, ऑल टू रेजिस्टेंस सॉरी। तो फर्स्ट only one resistance and 220 volt. So here first of all find I1, I2 and I3. तो I1 फाइंड करने के लिए पहले क्या करेंगे, हम ओम्स लॉ को लगाएंगे। तो I2 फिर ओम्स लॉ लगाएंगे। I3 तो सबसे पहले V इक्वल टू आई आर और आर एस इक्वल टू आर वन प्लस आर टू और आर पी इक्वल टू वन बाई आर वन प्लस वन बाई आर टू। तो coil used separately. Case 1 according to Ohm's law, V equal to I1 R. So I1 equal to V by R. So 9.166 ampere. And case 2 coil in series. So total resistance will be 48. So current will be I equal to I to RS. So I2 equal to V by RS. So answer will be 4.58 ampere. In case 3 coil in parallel. So total resistance in parallel. So 1 by 24, 1 by 24. So Rp equal to 12. So this is the according to Ohm's law, V equal to I3 Rp, V by Rp. So I3 equal to 18.33 ampere. In this way ये आंसर हमारा कंप्लीट हुआ। तो करंट फर्स्ट केसेस में 9.16 एम्पियर, सेकेंड में 4.58 एम्पियर और थर्ड में 18.33 रिस्पेक्टिवली। अदर क्वेश्चन जो है न्यूमेरिकल है, वो टाइप बी में हम पढ़े थे आर इक्वल टू रो एल बाई ए। तो रो एल बाई ए से कैसे सॉल्व करेंगे? तो हाउ मच करंट विल एन इलेक्ट्रिक बल्ब ड्रॉ फ्रॉम 220 वोल्ट सोर्स if the resistance of the bulb filament is 1200 ohm? How much current will an electric heater coil draw from 220 volt source if the resistance of the heater coil is 100 ohm? So first of all, first circuit 1200 ohm and I1. So and second circuit 100 ohm and I2, and same supply will be same 220 volt. So first circuit, first of all find I1, I1 and V2 R2. So first of all I1 equal to V by R1, V I1 equal to V by R1, R1 is 1200. So I1 equal to 20 by 1200 ohm. So answer will be 22 by 120. It means 11 by 60, 0.18 ampere. In similar way, in second way, V2 equal to I2 R2. So V2 equal to 220 volt, I2 and R2 is 100. So I2 equal to 220 by 100. So 2.2 ampere is the current flowing in the second circuit. And in similar way, current through the bulb is 0.18 ampere and current through the heater is 2.2 ampere. The potential difference between the terminal of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? So the potential difference is 60 volt and it draw 4 ampere. What current will the heater draw if the potential difference is increased to 120 volt. So here potential difference is 60 volt, current is 4 ampere, and what current will heater draw? So first of all find current. Current equal to voltage by resistance. So here R is 60 and I equal to 4 ampere. So resistance is 15 ohm. And next, how to find current? So voltage is 120 volt. So first of all find current. So I equal to V by R. So V is 120 and R is 15. So 15 at 120. So I equal to 8 ampere. And what will be current if the potential difference is 120? So current will be 8 ampere. And next question. The resistance of a metal of length 1 meter is 26 ohm at 20 degrees C. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal at that temperature? So here length of wire is 1 meter, diameter is 0.3 mm and R is 26 ohm. So first of all find resistance radius. So the radius will be 0.15 mm. First of all convert into meter. So R equal to rho L by A. So rho equal to R A by L and A equal to pi R square. Put the value and we get 1.48 into 10 to the power minus 6 ohm meter for metal. A wire of given material having length L and cross section area A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and area of cross section 2A? So here this is a wire L by 2 and for first wire R1 equal to rho L by A and for the second wire R2 equal to rho L by 2 by 2A. So here R2 equal to 1 by 4 R1 and 1 by 4 into 4. So R2 equal to 1. So resistance of new wire is 1 ohm. When a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. So here V equal to IR 2.5 milliampere and find the R V by I. So V is 12 volt and I is 2.5. So 4800 ohm is the resistance of resistor. Let the resistance of an electrical component remain constant while the potential difference across the two ends of the component decrease to half of its former value. What change will occur in the current through it? So according to Ohm's law, V equal to IR. Now the potential difference is reduced to half. New potential B dash equal to V by 2. Resistance remain constant. So I equal to V dash by R. So new current V by 2R. And the V by 2R, the current through the component will also be half. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor and 8 ohm resistor and a 12 ohm resistor and a plug key. All are connected in series. Redraw the above circuit putting an ammeter to measure current through the resistor and a voltmeter to measure potential difference across 12 ohm resistor. What will be the reading in ammeter and voltmeter? So all three are connected in series and 2 volt cell is connected also. So here and voltmeter is across the 12 ohm. So what with the reading of ammeter and voltmeter? So first of all solve this. Since all three are in series, so total resistance will be 25 ohm and current is P by R. So here 0.24 ampere across the resistor of 12 ohm potential difference V equal to IR. So 2.88 volt. So ammeter reading 0.24 ampere and voltmeter reading. Thank you bachcho. Please like and subscribe my channel. For more information connect AIMS coaching classes. Thank you so much.